Let's start out with the Rigol DSA815-TG, a new spectrum analyzer on the market. It's about $1,500 with the tracking generator. And we're going to take a quick look at what I found with the feature set on this particular instrument. Turn on the button. It takes about 10 seconds for it to come up and to show us the screen. It's of course computer-based unit, therefore it takes a certain amount of time. And you see that it sweeps from 0 to 1.5 gigahertz. The noise level comes up minus 50.06 dB peaks up to maybe minus 50 peaks. But that's with a 1 megahertz receive bandwidth or resolution bandwidth, as the case may be. Video bandwidth is also set to 1 megahertz. So it's not surprising that we only see down to minus 50 dBm. Of course, we can change this by changing the bandwidth, because normally we aren't trying to look at something even 50 kilohertz wide, let alone a megahertz wide. So let's put it at something more reasonable, like maybe 30 kilohertz for two-way radio. We'll go up to the bandwidth button, press that. Receive bandwidth is at 1 megahertz right now. I could put it over to manual, but that turns out the thing is set up so that if all I have to do is go 30 in kilohertz, it'll automatically go to manual. Now, of course, our sweep rate has dropped down to about 1.6 seconds. That's the entire screen, by the way. But we've dropped our noise level by 20 dB, which is about what you'd expect. First thing I'm going to do is plug in a 2-meter antenna that I have on the roof. It's a whip antenna, the mobile type, but I've put it on one of the vents up there. And it covers the 2-meter amateur band, but it'll cover a good portion of the VHF spectrum as well. Take the cable, which I have an adapter on here, to get it into a BNC connector and put it on the connector here. And as you see, we do have some FM broadcast signals down here near the bottom. We'll prove that. Hit the peak button, which is right here, and it goes down to the peak, which is 105 megahertz, probably 105.1 in this wide sweep. Of course, the accuracy is not exact. So let's look at that FM broadcast band, see what's there. Hit the frequency button, hit the start frequency. The bottom of the band is 87 megahertz, not kilohertz, 87 megahertz. The top frequency, or stop frequency in this case, we'll go 109 just to go outside the band a little. And as you can see in the FM band in the San Francisco Bay areas, we have a lot of stations. The highest one is this one, which we found before was 105. Hit the peak again and it'll come up, 105.6. It's actually 105.7, but now that we have the better resolution, we actually are getting a lot better frequency discrimination. I found this unit to be quite accurate on its frequency callouts. Let's look at the 1 megahertz near this frequency. So 105 to 106. Go back to frequency. Start frequency 105.000 megahertz. And stop at 106.000 megahertz. Now we're seeing the two stations that happen to be in that spectrum between 105 and 106. You also notice that there's an interesting pattern on the modulation on the stronger station here. That's because it has HD channels on it, which actually are 20 dB down, fit in the FCC mask for frequency spread, and that's where HD radio actually resides, is on the sidebands of the 105.7 frequency here. If I wanted to look at that over time, I could do one of two things. I could hit max hold for the trace, so let's do that. It's clear right now. We'll go to maximum hold, and there we go. We see that this frequency is normal. That's the second adjacent channel. First adjacent would be right here, and that's where this comes up to, but of course in any given area this first adjacent will not be used. Now if you're in a transition area, then you might not like HD radio because it might be on a station you want to listen to. But as you see, we have the mask now of what this one is doing. We have the mask of what this one is doing. And we have the edge of the one down here, which is probably at 104.9. We can do this clear across the FM band if we wish to. What if I want to look at the modulation relative to the mask? Well, I do have more traces. I hit the trace button. I go to trace 2. It's presently blank. I go to clear right. Aha! Now we have an interesting set of circumstances. We can look at both the mask overall, over time, and we can look at the mask instantaneously as it sweeps through. So this is sometimes helpful if someone is trying to figure out exactly what their modulation looks like. I did say that this was a 2-meter antenna we're on, so let's go up to the 2-meter amateur band and look from 143 to 149 just to get beyond the band edges. That's very easily done, again, by going to the frequency start and stop frequencies and changing them to 143 and 147. Frequency, start frequency, 143 megahertz. Stop frequency, 149 megahertz. You notice that our max hold is keeping this trace here, so we will want to take the trace type and go to number 1, which is the yellow one, and go back to clear right, and maybe turn off number 2 by going to blank. You notice that we're not seeing too much on the 2-meter amateur band, but of course these signals are much, much weaker than signals on the FM broadcast band by about 100,000 watts to 1 kilowatt maximum, and most of them are 100 watts. So we need more sensitivity here. That's easy to come by. We just turn on the preamp that's in this particular unit. Go to amplitude. Go to screen 2, see the bottom here, and turn on the preamp. And you notice that the noise level dropped down. However, we still don't have enough sensitivity because we need probably 20 dB more. Well, there's a reason why we don't have that 20 dB, and here it is right here. We have 30 dB of input attenuation to protect the front end, which we don't really need on this band because the signals are not that strong. So again, we go to input attenuator and make that 10 dB. I always would leave 10 for safety. Now we have a sensitivity of -100 and there's a signal on the 2 meter band. There's another signal that just came up there. And there will be signals popping up and going away all the time along here. If I want to get rid of some of this noise, I'm still at a bandwidth of 30 kilohertz. 30 kilohertz is probably more than we need because most of the signals are narrowband. So let's go to 10 kilohertz. Bandwidth. 10 kilohertz. Now we've dropped down to a sensitivity of about minus 102, something like that, which is probably fine to pick up most channels that would be usable on the band here. Remember, we do have some antenna gain up there as well. But I can knock down this noise a little more because all we need is 3 kilohertz worth of audio or video bandwidth because of the frequencies involved. That would be video bandwidth, which is on auto, which always tracks the receive bandwidth. And what I will do is just change that to 3 kilohertz by going 3 kilohertz. It slowed down the sweep time, but it gave us much less noise. Now we have about a microvolt of noise, which is probably good enough to see almost anything that's on the band that you'd be listening to. We have two signals on right now. Third one came on. Another one came on. Let's do the same thing we did before. We'll look at the instantaneous signals along with the composite of the whole thing by starting trace 2 and leaving it on max hold so it gets everything and maintains it. Trace. We're on 2. It's blank right now, as you see here. We'll go to max hold. This is a lesson in communication, that is, that it's intermittent in nature, i.e. you get on, you say what you need to say, somebody says something back to you, then you go away. Call it time domain sharing if you wish, but anyway, each of these channels is active, but each of these channels is not active all the time. And we're seeing that here by having the maximum hold turned on so that it maintains the signals that have gone away. Now, if I want to find out who these guys are, I can get the frequencies. And the way I'll do that is to turn on the markers and search for peaks. I hit the peak button here, and it gets the highest peak. I can go down to the second range down here. There's a peak table. Press that button. We want to look at frequencies. We'll leave it on normal and turn the state to on. Now we're seeing different peaks as they occur. However, the sensitivity doesn't seem to be too good on the lower peaks. It's not picking them up. Well, there's a place to take care of that too. And that's the peak parameters. Peak parameters lets us adjust that. Right now it's set to only see peaks that are above minus 90. That's right here. Let's make that minus 102, 102 minus dBm. And the excursion is limiting us because some of these are less than 10 dB out of the noise. So we will go 5 dB out of the noise. And as different peaks come up, we'll see them added to the list and removed from the list. As I showed you before, not all of these stations are on at the same time. Therefore, we have to have a station before it's going to read the peak. To demonstrate this, I guess I'll turn off the max hold channel, which is the trace 2 channel. Let's get rid of it, put it on blank. Now you see all 3 peaks are on there. There you saw a few more come up. Now there's one other thing we can do. We'll turn back on channel 2. We'll let it collect a few things. All right, we should be able to see all 4 of those if we simply do a peak hold on only that trace. I blanked number 1, which is our instantaneous channels, and left the ones that have been stored. Now you see that all of these peaks have been collected and put into the list down here. So now we know all of the channels, up to 7 channels, that have been on since we started this little exercise. So I hope that helps you to show how this unit can be used to look at spectrum. Just a simple demonstration, and it's a very handy tool for that. I can print this out by simply hitting the print button over here. If I do that, it says missing media because I don't have any media plugged in. I got this handy dandy little media flash drive, 8 gigabytes. This is a digital thing. Anyway, this is made by Kingston and got it at Fry's for $6 or something. Plug it in here. Now when I hit that, I get this. This screen lets me name something if I want to, or I can just hit this button down here and make it number 1. We'll just do that for the sake of simplicity, so we'll go 1. It's 1. And we'll hit OK, and it saves it to the media. Now we have a record of what happened on this band over the period that we were looking at it. You can, for example, listen for an hour or 2 hours or whatever, all day if you want, and find out what the activity is all day long on how many of these channels are actually active. And so it's very useful in that case. Those who do commercial two-way might put it on a site and do the same thing because they've got some kind of interference they can't run to ground. It's something that's got moved onto the site, and this would allow them to monitor, say, for a day and find out who's blanketing their channel that wasn't there before. And this happens every once in a while on two-way sites because there's a lot of people up there.